1.2 units. Just pretty easy. I think we're just gonna go over basic units. So we have the SI system, also known as the metric system, and it's the international standard. There's actually a joke with chemists because chemists hate the SI system. They use anything but the SI system. They'll use other methods of denotation, but the SI system uses meters, kilograms, and seconds. Um, so um, Another system that is centimeter, gram, and second. Just different ways to denote. And CGS is just this divided by 1,000, I guess, except for the seconds, which stays constant here. But the length, it's just meters, kilograms, and seconds. I'm not too sure if you have to memorize that, but it's pretty easy. Um, so we'll move on to the next slide. Modern definitions. So a meter is the distance the light travels in 1 divided by 2, 99999 seconds. Let me think. I don't know why I put the S at the end. But as we know, the speed of light is 3 times 10 to the 8 meters per second. So using some dimensional analysis, that's what they denote meter as, which is quite interesting because, you can denote meter objectively in other standards. But the book chooses to do this. It's kind of like periods and how periods have a cycle. Um, and frequency is just the reciprocal of that cycle. So just like the speed of light, the meter is just the reciprocal. So that's the logic behind there. The kilogram is a mass of platinum iridium standard. So yeah, that's just what a kilogram is denoted as. And these are using very broad definitions, or not broad. These are actually quite specific. Sorry, not broad. They're very specific. Um, and as you can see, a second is denoted as this many cycles of cesium of the isotope 133 radiation, which is actually interesting because I've known about this before. But now just thinking about it, it's a whole lot crazier that that's what a second is defined at. It's so precise. And that's the thing. Base units are fundamental: length, mass, and time. Derived units, which, for example, force is mass times acceleration. So that uses a base unit and derives another unit. Metric prefixes are just powers for scaling, so 10 to the third power. Really simple, basic, I guess, algebra 1 stuff. I wouldn't say 8th grade. So here we have the metric system, and I'm going to close my eyes here, and I'm just going to tell you it so I can know that I have it in my head. So tera is 10 to the ninth. We have giga, which is 10 to the, or sorry, tera is 10 to the 12th, giga is 10 to the ninth, mega is 10 to the 6th, kilo is 10 to the 3rd, hecto is 10 to the 10 squared, um, deca is 10. The regular one, which is, I guess, meter, we'll use meter here, is just 1, or, yeah, just 1. Um, Deci is 10 to the negative 1. Centi is 10 to the negative 2, which 1 cent, 100 cents to $1, pretty self-explanatory. We have milli, which is 10 to the negative 3. Micro, 10 to the negative 6. And then I believe we have um, nano, pico, and femto. So nano is 10 to the negative 9. Pico is 10 to the negative 12. And femto is 10 to the negative 15. I don't have femto on here, so it's kind of the logic behind it. So use these notations. These are pretty simple. I don't think you have to memorize a symbol. I'm not even sure if you have to memorize this. I'm sure conversions will be given on the test, but this is just kind of easy. So let me go over it again. Tera is 10 to the 12th. Giga is 10 to the ninth. Mega is 10 to the 6th. Kilo is 10 to the 3rd. Hecto is 10 to the squared. Deca is 10. The regular one is meter. Deci is 10 to the negative 1. Centi is 10 to the negative 2. Milli is 10 to the negative 3. Micro is 10 to the negative 6. Nano is 10 to the negative 9. Pico is 10 to the negative 12. And femto is 10 to the negative 15. So that's just the logic behind it. Memorize this, get it down, and you should be fine for physics. So